So let us understand how the vectors differ from scalars. So this is one of the elementary things that we need to understand in physics, and this is a question which will be asked again and again. So scalars and vectors. Okay. So scalars are quantities which require only magnitude. So what do we mean by magnitude? So for example, one of the very common example of scalar is mass. So just to define mass, we just require the magnitude. That is, we just require how much quantity is there. Have you understood, Chris?
Yes.
So for example, if I ask you another very common example of scalar quantity is time. So if I ask you the time, you just need to tell me the time. That is it. Or say another very common example that is taken for scalars is speed. So if I ask you what is the speed of the car, you will tell me that it is 60 kilometer per hour. Now just compare this with vector quantities. Now vector quantities, and that is how we'll understand the difference between scalar and vector. Now vector quantity, these physical quantities require magnitude as well as direction to express them. So the most common examples of scalars and vector that we need to understand is speed, velocity, and distance, displacement. Have you understood?
Yes, sir.
So these are very, very common, and they will help us to understand the difference between scalar and vector quantities. So, for example, if I say the speed of the car is 60 kilometer per hour, but if I say the speed is 60 kilometer per hour in north direction, now because
Yes.
I have mentioned the direction also,
Direction.
now it will become a velocity. Are we clear?
Yes.
Now, when I say I have traveled 10 kilometers, then it is distance.
Yes.
I don't need to mention the direction, but when I say 10 kilometers towards east, then it has become displacement. Have you understood?
Yes.
Now, this becomes very important because what will happen is, so for example, let me give you a very, sort of very funny example. Chris, one second, one second. So this will, result in very funny situations. So for example, you start from here. So let me define the directions first. So we shall eat now. So let us assume that you start from here. Now you go 5 kilometers towards this side, and then you turn back, and on the same straight line you turn back 5 kilometers. Have you understood, Chris?
Yes, sir.
Now here the sort of funny situation becomes that the distance travel is 10 kilometers, but the displacement is zero. Have you understood?
Yes, sir.
Because what you did was you did the first 5 kilometers was towards east, and the next 5 kilometers
Goes towards west.
was towards west. So that is why the displacement, because displacement requires the direction also. Now distance doesn't require the direction. So for example, from your building, you take a auto, then
Yes.
you roam around for 1 hour and you come back, and then you tell the auto wala that the displacement is zero. That is why I won't pay you anything. Have you understood?
Yes,
So,
sir.
sorry. So this will, give rise to all kind of funny situations where, the magnitude is there, but if you take the net direction might, as per the vector addition, the resultant answer would be zero. Now, another thing that you need to understand is you will do that chapter in maths also. That for adding and subtracting vectors, you require the uh, there is a separate topic in maths which is taught vectors. So they follow the rules of vectors. Have you understood what I said?
Yes, sir.
So that is why they have written that vector quantities follow different algebra for their addition, subtraction, and multiplication. So this is a topic which is done in maths. You will be doing this in maths. So vector addition, vector subtraction, vector multiplication. 1 second, Chris. Sorry, yeah. 1 second.
Yes, sir.
Actually, there is nobody at home, so that is why I have to, open the door again and again.
Yes.
So, when they teach you vectors in maths, and then you'll understand that the operations that are used for vectors are completely different, and how it becomes in physics, how this starts becoming crucial for us is, so for example, we need to understand that the quantity that we are dealing with, whether it is a vector quantity or it is a scalar quantity, slowly it will become very once you start doing more and more physics, you'll understand. So, for example, this is acceleration, this is momentum, this is force. Now, these are vector quantities, but mass, time, volume,
Taylor.
yeah, these are scalar quantities. The mathematical operation, for us, the important thing is the mathematical operation which is used here would be completely different from the math which is used here. Have you understood?
Yes.
And in iGCSE syllabus, you have I think you would have done some numericals in school also, where they would have told you how to add vectors like force, how to add forces and how to subtract forces. I think they might have discussed that. Uh, either ways, we'll have to
Yes.
discuss. Yeah, either ways, we'll have to discuss because that is part of the syllabus. So the point that I'm trying to make is that we should be very clear when we are studying physics that what kind of quantity that we are dealing with, because as per the quantity that we are dealing with, so for example, if I understand that mass is a scalar quantity and I have to add masses, then I understand that because it's a scalar quantity I can just do a arithmetic sum. So that is what they are saying, that scalar quantities can be added, subtracted, multiplied by simple arithmetic methods. So any of these quantities, mass, length, time, distance, density, volume, speed, temperature, potential, work, energy, power, pressure, quantity of heat, specific few of the quantities won't understand, but down the line you'll begin to understand. So the point is you should be very clear that when you are dealing with quantities like these, you can do simple arithmetic addition and subtraction. Now the problem becomes that there is a quantity which is a scalar quantity. So the examples of scalar quantity we have, few of the we discussed. So for example, displacement and velocity. Then acceleration, momentum of force, impulse, weight, temperature, electric field, magnetic field, dipole. All these are vector quantities. Now to operate the vectors, so for example, you are trying to add two forces. You can't use simple arithmetic operation to add two forces. So for example, I'll give you an example also. So for example, there is a force of 5 Newton in this side, and there is a force of 5 Newton in this side. Now, if I do simple arithmetic operation, then I'll say that the total force is 10 Newton, which will be completely wrong. Have you understood my point? Chris, have you understood my point?
Yes, sir.
So whenever you are dealing with any physical quantity, any quantity in physics, you should be clear that whether it is a scalar quantity and whether it is a physical quantity, because the operation that will be used will be different. And this is a question which is often asked, and point wise they have given a very beautiful answer that for scalar quantity, you just require the quantity being measured. So basically, you require just the numerical value of the quantity which is being measured and the unit. So for example, if mass is there, then I know 5 is the numerical quantity and kg is its units. If I'm discussing time, then 5 is the numerical quantity and r is the unit. But when I'm discussing a vector quantity, then I need three quantities. One would be the numerical quantity, that is 5, the unit which will be Newton, and
Yes.
then I should be specifying the direction also. Let us assume towards north. Have you understood what I said?
Yes, sir.
So The point that I'm trying to make is that there will be few quantities in physics where you will be, you know, you might have a confusion. Then you need to check whether it is a scalar quantity or a vector quantity. And these are the quantities that usually will meet in the first few chapters of physics. So, for example, we discussed speed, velocity, distance, displacement. And another very common example that is taken is mass and weight. Now, mass is expressed in kg. Oh, weight in
So
common
expressed
language.
in Newton.
Yeah, shabash. So, in common language, they seem to be the same. In
Yes,
common
sir.
language, we'll say, what is your weight? So we'll say the weight of this table is, or the weight of this chair is. But we need to understand that when we are dealing with physics, these things in common language, speed and velocity might be the same. They can be changed. People can either use speed or velocity, distance or displacement, mass or weight. But when we are dealing with physics, we should be very, particular that what is that we are dealing with. Have you understood?
Yes, sir.
Now I'll give you another very, sort of a funny thing, a funny example. So, for example, in chemistry, you'll do something called molar. You'll do a topic called mole. Now, when you do mole, usually the people in chemistry they'll say molar weight, or they'll say molecular weight. But and they'll say the molar weight is 18 gram, or the molecular weight is 36 gram. But as a physics person, we should be very particular that this 18 gram just can't be weight, it has to be mass. Have you understood what I've said?
Yes,
You will see this in written in chemistry books also. But as a physics person, as a person who understands physics, we shouldn't be doing these kind of mistakes. Are we clear about the difference between scalar and vector?
yes, sir.
Okay. So another thing, I'll send you the scan of this particular column. Uh, you should be very clear about the difference between distance and displacement also. So in one way or the other, this might also be asked. You should be clear. So distance is
Yes,
a scalar quantity, displacement is a vector quantity. It is always positive. It can be positive or negative as per the direction. So this is one of the important differences. Are we clear till here?
yes, sir.
Great. Because this is, I wanted to cover this because if you see your syllabus, if you see your physics syllabus, this is one of the topics. So if you see, this is one of the first topics that they talk about. So if you see scalar, uh, vectors, graphically, this is what I was talking about. Calculation of graphically by resultant of two vectors at right angles limited to force or velocities only. So this is one of the topic they might have done, and we will also do how to add two vectors. How to add two vectors. So for example, this is 5 Newton acting. This is say let me call this is 3 Newton, and this is 4 Newton, and the angle between them is 90 degree. So how to find the resultant of these two vectors? Chris, is it making sense?
Yes, sir. Yes.
Great.